Okay, section 5.4, medians and altitudes. We're going to identify properties of medians and altitudes of a triangle. There's going to be two main theorems that we're going to do here as well. The last section we did circumcenter and incenter. Today we're going to do two others. So when you look at the four of them together, it's a lot. That's why I kind of broke up the test like I did. I kept two of them in the first test. Now we're going to do the second two, so you don't have to know them kind of all at the same time, because it is kind of a lot. The first one we're going to look at is the medians of triangles. It's a segment whose endpoints are a vertex, and it goes to the midpoint on the opposite side. So it kind of makes sense. We talked about medians already, and the median means midpoint. A triangle's medians are always concurrent. That means they always cross somewhere in the middle. Okay, so this theorem you will want to copy. And what I would like you to write beside this one, or above it, or whatever, is centroid. And make sure you put both. Some questions ask for the concurrency of the medians. Some questions just say, I want to know the centroid. So at least if you have them both on there, you'll be able to look and go, I don't remember which one this is. I can find it then when I look. Here's what it says. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint on the opposite side. Now, notice these formulas are all pretty much the same. You can do the picture if you'd like. The formulas are all the same, and I will explain it this way, and I'll also explain it in a way that I feel is easier. Okay, so it won't necessarily be using this theorem, but it's kind of just taking it just one step further and bringing it down a bit more. So DC, so I'm only looking at this one. DC, this part right here, is 2/3 of the way across. Okay, so when you look at it, this part right here would be 2/3, and this part right here is then 1/3, correct? Because 2/3 plus 1/3 equals 3/3, and that equals 1, which is all the way across. So keep that in mind. What they're going to do is they're going to give us numbers in different places. Sometimes they'll give us the whole entire length. Sometimes they'll give us the DC part. Sometimes they'll give us the CJ part. And then they're going to ask us questions, and we need to find the other two. Okay, so that's kind of what we're kind of gearing toward. And again, this one is the centroid. We're going to do a paper folding activity on Thursday, which and it's kind of hard, but we're going to do it anyway. Hopefully it will make these make sense as well. So we're not doing constructions here. We're going to do a paper folding activity on Thursday. And that actually is your assignment for Thursday.
We have to make that up.
Yes. Yep, that'll be your assignment for the day. So if you need help with it, then come like Monday or something, when you get back. If you don't, you can certainly, it's something that you can do at home. So let's look at a question. They kind of explain centroid here, the point of concurrency of the median. So if you go from the angle to the median across the other side, the angle to the median across, and the angle to the median across, where those cross is the centroid. So that's that point in the middle somewhere. This is called the center of gravity point because it's the point at which a triangular shape will balance. So if this surface right here was a triangle, and I had a board or, whatever underneath it, if I found the centroid, I could balance it exactly at that point. Okay, so remember that because that's probably a question you'll see again. So the point where it's going to balance is going to be the centroid. It's always inside the triangle. So let's look at one right now. So it says in the diagram below, XA equals 8. So that part right there is 8. What we want to know is how long is the whole thing. Okay, so I'm going to first do it like the theorem says, and then I'm going to explain it in a different way. And whichever way works for you, go ahead and use it. So according to the theorem, and I'm going to zip back up and look at it one more time, just so you know kind of where I'm getting this from. If we look at this DC one, we have DC, correct? Okay, so that's the shorter one. So notice that's the part that's by itself. We take 2/3 of the entire length, and that equals that longer segment. Okay, so if we have the longer segment, which we do, we're going to set 8 equal to 2/3 of the entire segment XB. Okay, so you take the letters exactly like they are, except the letters are going to be different every single time. That's why it's hard to do, hard to kind of take you from the theorem to this, because you kind of have to change it every time. So if we were trying to solve this thing, we would either divide by 2/3 or multiply by 3/2, the reciprocal. So I'm going to multiply by 3/2. The 3 cancels the 3, the 2 cancels the 2, and I have to multiply this side by 3/2 as well. 8 times 3 is 24. 24 divided by 2 is 12. So XB equals 12. You do have to label them now, because there could be a variety of other things, not just one that they're asking us to find. So they might say, okay, I want to know AB, I want to know CZ, and I want to know YA. So you have to label them so I know which is which. If you don't, I won't give you credit. Now, how do we do this the other way that I was talking about? Okay, I'm going to go back to the 1/3, 2/3 things, but I'm not really going to use them. Okay, so when I look at the 8, is that the 1/3 part or the 2/3 part? It's the 2/3. Now, let's just look at 1/3 and 2/3 just alone for a second. Okay, just kind of look at them just all in their own. How many times bigger is the 2/3?
1.
Isn't it 2 times bigger? So 1/3 plus 1/3 would be 2/3, so it's like 2 times bigger. So what happens is if we know the little one, this little part right here, we could double it to get the 8. Okay? If we have the big part, we could half it to get the small one. Okay? So for instance, if we needed to know AB right now, what I would do is I would take 8 and divide it by 2 and get 4. Okay, now how much is 8 plus 4? 12. Is that not the whole thing that we just found? It is. Okay, so if you do half and double, you will get the smaller two things, and then all you have to do is add them together. Okay, and you wouldn't have to remember, is it 2/3, is it 1/3, what am I doing? You don't have to remember any of that. Okay, so in this one, AB would be 4, XA is 8, and then you would say 8 plus 4 equals 12, and that's how they got that as well. Okay, I feel like that's much easier when you do half double. So the AB is 1/3 of the way across, the XA is 2/3 of the way across, and they are 2 times different. Okay, so let's do another one. So in the diagram, ZA is 9, so I'm going to do this one in a different color. What is the length of ZC? Okay, so ZA, this one right here, is 9. They want to know ZC, the whole thing. Okay, so if we do half double, is the 9 the bigger part or the smaller part?
Bigger part.
And what do we do to find the smaller part right here? Half it, so that would be 4.5. What is 4.5 plus 9? 13.5. Does it matter that's a 0.5? Nope. If you take 9 times 3/2, do you still get 13.5? You should, because here's what it would be set up like. 9 equals 2/3 of ZC. You would multiply by 3/2. That would be 9 times 3 divided by 2, which would be 27 divided by 2, and you get exactly the same thing. So whichever way you do it is totally fine. I think half double works so much easier and so much faster. Most of us are not really fractionally inclined, and we do know how to half and we do know how to double. So I feel like that's much, much easier. So the first thing we did was we took 9 divided by 2 to get the shorter length, and then we added the two together. Okay. The altitude of a triangle, if we have time, we may go back and do a couple of these. If not, we'll do a couple more tomorrow before your assignment is given. And we'll just go until we run out of time. The second part of this section is the harder part. So this is definitely the one that you do want to write steps for, and you want to do exactly what you need to know what the process is. The altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. So it's kind of like the other one where we went from the angle to the midpoint. Here we're going to go from the angle, but we're going to make it perpendicular to that other side. And that's where it makes it a little bit trickier. This one can be inside or outside the triangle, or it can be on the side. So centroid is always in the middle, kind of like incenter is always in the middle. But the orthocenter, which is what we're going to call this one, can be kind of anywhere. Okay, so I'm going to zip down here to this one. Go ahead and write this one down as well. It's the concurrency of altitudes, and like I said before, this one is the orthocenter. Please write both of them just in case they use concurrency of altitudes or orthocenter. Either one works. The lines that contain the altitudes of a triangle are concurrent. So it doesn't tell you a super amount about it, but we're going to go back and we're going to kind of go through step by step so we can kind of tell what we need to do. Okay, so second example. Notice this one will look different because you'll see some right angle symbols in it. So you're going to be able to tell which one is which, probably just because of those right angle symbols. It says for triangle PQS, is PR a median, an altitude, or neither? Okay, so let's describe them both, or describe them all. If it is a median, it goes from the angle to the midpoint on the other side. Okay, so I'm looking specifically at Q. They're looking at PR though, okay? If I said, is QT a median, an altitude, or neither, what would you say? QT I'm talking about, this one. What one is it? Does it make a right angle or does it cut it in half? Cuts it in half. So for this one, QT is a median, but is PR a median? Does PR right here cut anything in half? No, it's not even inside the triangle, okay? So that's kind of the difference, okay? So when you're talking about it, an altitude makes a right angle. Okay, so is PR something that forms a right angle? Yes, that's how you tell. Okay, if you don't see either one of those things, then it's neither. Okay, you can say it doesn't cut a side in half, which is the median, and it doesn't make a right angle, neither. Okay, so we are going to say this one is an altitude and call it good. They didn't say anything about QT, so I'm not going to really say anything there. I just wanted to show you what they look like. Explain PR forms a right angle with RS. You could also say QR, you could also say QS, as long as you name the line. So this part, not the hard part. The next part when we actually use the theorem is the harder part. Okay, here's another one. Same picture. Now they're talking about QT. What did we say QT was? The median, because this part right here goes from the angle, and you also see these two things, which cuts it in half. So this one is a median. QT bisects PS. Okay, or it cuts PS in half, or any wording there is fine as long as you get the half part right. Okay, so here is each segment a median, an altitude, or neither? And they're talking about the segments that go through the middle. So let's do CF first. What is that one? Because you see what? The right angle. So we're going to say altitude. And in parentheses, I'm going to put right angle. And that's good enough for a description as long as you kind of say, you know, what you're looking at. How about EG?
Neither.
Okay. And it is neither. And I can see where you wanted to do median because when you look at EG, it cuts this in half, doesn't it? But what were those called when they went straight across? They were not median, they were mid-segment. So EG is really a mid-segment. And the reason is because it doesn't go to the angle on the opposite side. So this one right here would have to go like this. Or like going to A, which you can't because it's already a side. Okay, so if EG was where EB is, then it would be a median, but it's not. I'm going to say neither. It's a mid-segment. Okay, now let's do AD. What is that one? That one is a median because it cuts this side in half and it also goes directly to the angle on the opposite side. So we are going to say median here. And I'm going to say goes from angle A to bisect BC. Something like that. So you guys will have to do some of those tomorrow. I guess I did them already. Now we're going to go to the ortho center. This is the one that is the hardest one. I think this is one of the harder problems that we even do for the year. Outside of proofs. Proofs are hard anytime, but this is one of the harder ones, not because you don't know how to do each step, it's because it's 3 steps long. And you have to know how to put it together and what to do on each one. So orthocenter, the lines that contain the altitudes of the triangles are concurrent here. This kind of tells where they are. So if you have an acute triangle, what happens is you're going to do the perpendicular one to this side on the right. Perpendicular, and it has to go to the angle. You're going to do this one, it has to be perpendicular. This one has to be perpendicular. So if it's acute, the orthocenter is going to be on the inside. Okay, so you don't have to draw the triangle, just put acute inside. Kind of like what we did when we did those constructions. We did the circumcenter. We did an acute triangle, it was on the inside. A right triangle, it was on. And then an obtuse triangle, it was outside. So think about it kind of that way. In a right triangle, where is it? On the hypotenuse, only it just doesn't cut it across the middle. So right triangle on hypotenuse. And then obtuse triangle, it is on the outside. However, it's on the opposite side that we did the circumcenter. Circumcenter was out here. Orthocenter's on the other side. Okay, so keep that in mind. So obtuse, outside. So this is important when you guys have to graph 3 points. First, you're going to decide what kind of triangle it is and where it should be, because then when you draw it in there, you're going to know, did I get this one? Did I not get this one? Where is it supposed to be? At least if you have an idea, then when you're done, you can go, yep, this is where it's supposed to be. Okay, so grab a piece of graph paper and do this one with me, please. And we'll go until we run out of time, and if we run out, we'll just start again with this one tomorrow. So if you don't have graph paper, there's some in the bags up here. You just need one for today, but if you need some, you can grab a sheet. So the first thing you're going to do is graph A, which is 1, 3, B, 2, 7, and C, 6, 3. And they want to know what are the coordinates of the orthocenter. And for these, you're going to have to do specific things. There are steps involved, so you can be as wordy as you want to be for those steps. Okay, so the next thing that we're going to figure out is how do they get those lines where they are? That's what we're going to do. So that's what you would have to come up with. You would only have the ordered pairs, not the lines right now. So step 1, you're going to choose a side. Doesn't matter which side you want. Let's do BC first. Okay, so choose a side. I'm going to say BC. Find the slope. Okay, so find the slope of BC. When you look at it, remember to find slope, you're going to do rise over run. If you want to, you can go like this. Count the squares. It's 4 up and 4 across. The slope would be 4 over 4, which is 1. And then is it positive or negative? Negative 1. Okay, and I'll go like this. Negative 4 over 4, and that reduces down to negative 1. Okay, or when I'm looking at it, what I would look at is go, oh, this one looks like it's going down 1, right 1, down 1, right 1, down 1, right 1. That works as well because you only have to do one little triangle, and that would be negative 1 as well. But the ordered pairs work every time. If you don't remember how to do the triangle thing, you can always use the formula for slope, which we also have. Okay, so 4 over 4. Now, what we're going to do is we need to use the point across from it. So, point A, use point or vertex, so we'll go vertex, opposite. Okay, so we chose BC this time, and I'm going to make it very obvious which one we're doing. And we need to use the point across from it. So it cannot be connected to BC. You can't choose B, you can't choose C, you got to go to the opposite one. Okay, so we chose A. And what we're going to do is we're going to use that slope, and we're going to go up and to the right, up and to the right, up and to the right, because we have to make it perpendicular. Okay, so perpendicular slope equals 1. How do you do that? You flip the slope over that we have and change the sign. Okay, we talked about that before. So if this slope is negative 1 over 1, you flip it over, you still get 1. If you change the sign, you get 1. Okay. Now here is where you're going to start doing some counting. So from here you're going to go up 1, right 1, up 1, right 1, up 1, right 1. That's how they got that blue line in there. And then you can draw it in. Now you don't have to draw those triangles. You can just keep going. You're going to want to do a few of them. Some people, instead of doing the triangles like that, will go like this. Up 1, right 1, put a dot. Up 1, right 1, put a dot. Up 1, right 1, put a dot. And you can do as many as you want to. Draw the line in. Okay, I would do probably at least 3. So that's the blue line, and you guys can draw that in. Now, we do need an equation of this line. So how do we do that? Okay, so equation. Okay, the slope you're going to use, we already have. It's 1. And if we keep going, if we went this way, we could also go back, couldn't we? Left 1, down 1, left 1, down 1. Where does that cross the x-axis? 2. So can't we just write it in if we know what it is? Okay, so, oops, my words left me here. Okay, so my equation is y equals 1x plus 2. Okay, for each of these, you're going to need to draw the line in on the graph and come up with an equation. So we just did that. Okay, now we need to do it again for another side. Okay, now I'm going to do the easier of the sides, and I might run out of time. This one isn't quite as hard. I'm going to try to change colors. I don't know if it'll let me. Nope. Okay, so let's pick side AC. And notice what we did before. We found the slope of that. What's the slope of a horizontal line? We know one is 0. We know one is undefined, right? Which one is 0?
Horizontal line.
The horizontal. So how do you do something perpendicular to a horizontal line?
A vertical line.
Do we have to really figure out the slope though? No, remember when we said horizontal and vertical lines are always perpendicular? So what you need to know is this one is horizontal. We need to find that vertical one to do the perpendicular. Okay, so perpendicular would be vertical. What point does it have to go through? The point on the other side. So it can't be A, it can't be C because that's on it. It has to go through B. So we just draw a vertical line through B because that's where it's going to be. So draw a line through point B. Where do they cross? Name it. Okay, so step 3 would be 2, 4. Okay, now we're going to do another one of these right away tomorrow at the beginning because they are a little bit longer. Some of them don't work out this slick. Some of them might be all slanted, where you have to have 2 equations and then you have to solve those together, which is an Algebra 1 thing. So we're going to do one like that tomorrow just so you can see another one. We're going to stop right here. If you need to take more notes, go look at the video online, and then I'll have a second part to it tomorrow.